1, 2, 3.
Good day, viewers! I'm KAILAHRAIN MILIZIA ASILO of AB Psychology. Our video lesson for today is all about the Fibonacci sequence and the golden ratio. Mathematics in the modern world. First, I'm going to discuss the Fibonacci sequence. The history of Fibonacci sequence. Who invented the Fibonacci sequence? The Fibonacci sequence was invented by the Italian Leonardo Pisano Bigolo. Birth year 1170, death year 1240. Who is known in mathematical history by several names. Leonardo of Pisa, Pisano means from Pisa, and Fibonacci, which means son of Fibonacci. The most talented Western mathematician of the Middle Ages. Next slide. What is Fibonacci sequence? Fibonacci sequence is an integer in the infinite sequence. 1, 1, 2, 8, 13, of which the first two terms are 1 and each succeeding term is the sum of the two immediately preceding. To get the next term in the sequence, add the two previous terms. Did you know that Fibonacci sequence is started with a pair of rabbits? A baby boy rabbit and a baby girl rabbit. Fibonacci and the rabbit's problem. Suppose a newly born pair of rabbits, one male, one female, are put in a field. Rabbits are able to mate at the age of 1 month, so that at the end of its second month, a female can produce another pair of rabbits. In this visual, we can see here the process. We will know how many pairs of rabbits will be there in 1 year. At the end of the first month, they mate, but there is still only one pair. At the end of second month, the female produced a new pair. So now there are 2 pairs of rabbits in the field. At the end of the third month, the original female produced a second pair, making 3 pairs in all in the field. At the end of the fourth month, the original female has produced yet another new pair. The female born 2 months ago produces her first pair also, making 1, 2, 3, 4, 5 pairs in all in the field. Eventually, the number of pairs of rabbits in the field are 1, 1, 2, 3, 5, 8, 13, 21, 34. So, the first 12 numbers in the Fibonacci sequence are 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144. From that, we can see that after 12 months or at the end of the year, there will be 144 pairs of rabbits. Next slide. Does Fibonacci sequence appears in nature? Definitely yes. The Fibonacci sequence appears in nature because it represents structures and sequences that model physical reality. For example, the 3 branches. Branch or branches is a part of tree which grows out from the trunk. In the first and second line, we have 1 branch. In the third line, we have 2 branches. In this line, we have 3 branches. In this line, we have 1, 2, 3, 4, 5 branches. In this line, we have 8 branches. In this line, we have 13 branches. And also, in this line, we have 21 branches. As you can see in this visual, the total branches are also the same in the Fibonacci numbers. It is 1, 1, 2, 3, 5, 8, 13, and 21, which is the 8th term in the Fibonacci sequence. Do you have any idea what is golden ratio? Well, golden ratio appears many times in geometry, art, architecture, and other areas. The golden ratio symbol is the Greek letter pi. It's a special number approximately equal to 1.618. This symbol is what we call pi. Golden ratio is also known golden section, golden mean, divine section, or divine proportion. The golden ratio can be illustrated using this golden rectangle and the golden spiral. A golden rectangle is a rectangle that can be cut up into a square and the rectangle similar to the original one. Meaning to say, if you cut off a square side length equal to the shortest side of the rectangle that's left will have the same proportions as the original rectangle. Golden ratio. The ratio of the two quantities is the same as the ratio of their sum to the larger value of the two quantities. This example shows that this long line is the letter A. A is the bigger value, while this short line is the letter B. B is the smaller value, or equivalently as a proportion of A plus B over A equals A over B. Golden ratio can be found in nature. For example, snail shells. As you can see in this picture, the snail shell has golden spiral of a golden ratio. Next example, the hurricanes. We can also observe here that hurricanes has also golden spiral or what we call logarithmic spiral. Next, the golden ratio in DNA molecules. Yes, our DNA also is a part of golden ratio because the DNA consists two spirals, the red spiral and the blue spiral. Between two spirals' length, there are 34 and the width is 21. 21 and 24 is in Fibonacci series. So, 34 divided by 21, the answer is 1618 or 1.618. So, it has golden ratio. Let's have an exercise. Find the 19th term in the Fibonacci sequence. So, as I said earlier, to get the next term in the sequence, add two previous terms. 1 plus 1 equals 2, 1 plus 2 equals 3, 2 plus 3 equals 5. So you just need to add the two previous terms to get the next term. The answer is 4,181. Next, evaluate the following sums. Fib 14 plus Fib 20. In order to get the answer, we need to know the Fib 14 and the Fib 20. So, the fib 14 is 377, while the fib 20 is 6,765. So now, we are going to add the two sequence to get the total answer. 377 plus 6,765 equals 7,142. So, the answer here is 7,142. That's all for this video lesson. Like, subscribe, click the bell button to get notification. And comment down below if you have any question about this lesson, the Fibonacci sequence, and the golden ratio. Thank you for watching, guys. I hope you enjoy this lesson.
Hi everyone, I'm KAILAHRAIN